All right. It's right at noon here. I'm sure we've got some other folks trickling in, but we're going to go ahead and get started in the interest of starting on time. Thank you all so much for joining us today. My name is Emily Misseldine. I'm an Energy Management and Key Account Specialist with Plata Electric Association. With us today is my colleague John Kenny, who's going to be talking to us about the latest in electric heating technology. And really talking a lot about our options out there. And getting into heat pumps and all sorts of information here. Go over our agenda a little bit. So he's gonna touch on reducing our heating load, talk about indoor air quality, different electric heating options. I'm sure you've heard a lot about it these days, but we're gonna talk a lot about air source heat pumps and different heat pump technologies. Take a look at cost comparisons of other heating systems out there. Talk about LPEA rebates and tax incentives and how to get started pursuing and purchasing a new system for your home or business. We will be answering questions at the end. Feel free to put questions into the Q&A down below or hold on to them to ask live there at the end. Before we get started, we did want to kick off with a poll for you all today, so thanks for participating. We want to see who is here with us today. Please go ahead and take that poll as soon as you can. All right. Give another 10 seconds or so to get your answers in. Thanks to our tech support, Whitney Largent, for getting our polls going as well. All right, go ahead and close that out for us if you don't mind. Can we see the results? Does that pop up for us? Awesome. Great, so we got a great mix of folks, few who already have heat pumps installed, few who are curious and learning more and working on pursuing one and getting crazy or getting stuff going, and a couple and someone who thinks heat pump sounds crazy. Fair enough, but thanks for joining us anyways. And with that, I'd like to turn it over and introduce my colleague John Kenny. He's an energy management program architect here at Plata Electric, and he is a heating and electric systems expert. Take it away, John.
Yeah, thanks, Emily. They do sound crazy. Yeah. So yeah, we're gonna talk a lot about heat pumps. I'm gonna try and move kind of quickly through the presentation and leave a lot of time open for specific questions at the end here. So forgive me if I kind of move quickly, but our journey on heat pumps, we typically advocate for kind of cleaning up the home first. And so the thing we like to do first here is recommend just an energy audit, and that should be a BPI certified energy auditor coming in, doing something like a blower door test to depressurize that home and start to find out where we've got air leaks and lack of insulation in there. And so this is a great place to start. That energy audit will pay for itself just in being able to find some issues in the home. And then the net result there, what we're trying to do is lower the heat loss of that home so that we can potentially undersize that heat pump system. So you've got long-term savings from less heat loss in there and less heating load needed, and upfront lower costs because that heat pump system is actually smaller. So this is a great place to start. And so this little demonstration here is just showing all the little air leaks that can happen in a home, especially if you have lack of insulation, things like that. You're just pouring heat into the outside, and heat pumps really don't work well with poorly insulated and poorly sealed homes. So good place to start. As we're building homes now that are really well sealed and really well insulated, or we're going and retrofitting all those weatherization measures in there that are sealing these homes up, we also want to talk about ventilation, and that is for indoor air quality. So this is bringing fresh air in from the outside and then exhausting some of that stale indoor air, but doing so without losing all that heat. So this is a HRV or an ERV. It's a heat recovery ventilator or an energy recovery ventilator, and it'll actually capture that heat before it's exhausted to the outside, and that incoming air will be preheated as it's coming into your home. And this is how we get better indoor air quality, especially if we're using something like a mini split that we're going to see coming up here. We want to make sure that we're cycling fresh air into these really tightly sealed homes. So jumping right into kind of other types of electric heating, just to kind of give mention of what's out there. We've all seen space heaters, these kind of fireplace things, and baseboard heaters, things like that. They all work on electric resistance heating. And so the best that they're ever going to do is what we would identify as 100% efficiency, which sounds really high. But what we're talking about there is 1 unit of energy in, and we're getting 1 unit of heat back out. And we're going to see these heat pumps coming up here. They're doing about 4 units of energy back out for 1 unit of energy in. So we can do a lot better than baseboard heating and space heaters and things like this now. And one of those options is ETS. So we do have an ETS. This is electrical thermal storage program here at LPEA. We've had it for, I think, 30 years now. So this is a great option if heat pumps don't work for you. Especially if it's a vacation home that's unmonitored, or you just want something that's super low maintenance, zero maintenance essentially. ETS could be a good option for you. And this really takes advantage of our time of use rate program over here. It's a rate class that has an on and off peak period. So for 18 hours out of the day, you get this low off peak rate in which these heaters are actually storing heat into the ceramic bricks that you see there as a thermal mass. And then during that higher cost on peak period, they'll actually shut down. And then that blower in the bottom right that you see there will actually blow warm air out into your home. So still a great option there if heat pumps aren't going to work out for you. And then kind of jumping into, and this is our time of use rate as well. So this is how it works. So this is kind of the on peak periods and off peak periods that you see here. And whether you go with a heat pump or not, or you're going to go with ETS or not, always a good idea just to kind of evaluate, can time of use work out for you? And the way that it works out is if you can start to shift some of the loads in your home off peak, that's when we see it working out for people. And, we're always happy to talk with you about specifics on that and potentially run a historical analysis too, to see if this would work for your home. So jumping into kind of the meat of this, so heat pumps. So how do they work? Seems like magic. It seems kind of crazy, but really what we're talking about here is we're not creating heat in this system so much, but we're actually moving heat from one place to another. And so this little illustration here in the bottom right is showing that an outdoor coil or outdoor unit is really what we would call it. And then that's the blue and red piping that you see there running between those units is actually full of refrigerant. And so what's really happening there is in that outdoor coil, even in the middle of winter when it's 0 degrees, -5, -10 degrees out, there's still little bits of heat in the air. And so that little bit of heat is going to get picked up by these fins and a heat exchanger inside that outdoor unit. It's going to go into that refrigerant and then pass into that home and go through a couple valves in there. It's going to change from liquid to a pretty a higher heat gas through that compressor into the inside coil where it's now a high heat gas. There's another heat exchanger inside that inside coil. It's going to pull your room air inside of that, heat it up, and then pass it into the space. And now that refrigerant is cooler. It's going to go through an expansion valve where it's going to turn back into a liquid and into that outdoor unit again. And so this whole cycle just sits there and keeps going over and over and over again from liquid to gas, and passing heat into your home. And then in the summer, it's actually just reversing that. So now instead of pulling heat from the outside and pushing it into your home, it's going to take all the heat from your home and push it to the outside. That's why we call them heat pumps. Really, they're just pumping heat around rather than creating their own heat. And so the typical systems that we see, so there are a couple others out there that are pretty uncommon, but mostly what we're seeing here are either air source or ground source heat pumps. And so what we're talking about is what does the outdoor unit look like? So on the left-hand side, you've got an air source heat pump. So you've probably seen these sitting outside of people's homes now. They're getting pretty common. This is just taking that heat from the air and then passing it into that refrigerant line set. Whereas on the right-hand side, a little less common, that's a ground source heat pump. And so that's got a refrigerant line set actually buried in the field out there. It's actually not refrigerant, but glycol, typically water glycol mix. So it's taking the heat from the earth. You go down about a meter into the earth, and it holds about 50 degrees year round. So it's pretty consistent. And so we're able to either pull heat out of the ground or push heat into the ground through that outdoor loop. And that's how we can use ground source as a heat sink there. And then no matter what you choose for your outdoor unit, whether it's air source or ground source, the indoor units can have a bunch of different form factors just depending on your preference and what's in your home and kind of what's going to work out best there. And so kind of left to right here, we've got a central air handler. So if you have a ducted system or you're looking at a new home and you really want a ducted system, you can pull out your old furnace, put in a air handler there, and now you've got heating and cooling through that same ductwork that you already had in place. Mini splits or ductless heat pumps, these are probably the most common out there. They're also going to be the highest efficiency and probably lowest upfront cost typically. So this is one outdoor unit connected to one or more indoor units. So you could have up to 4 or 5 indoor units on a single outdoor unit, all of them just connected by that refrigerant line set that you see there coming in through the wall. And then those are just wall mounted, so you can typically put them up near the ceiling that you see there, and all it's doing is pulling that room air in, heating or cooling it, and pushing it right back into the space. A little less common, so the ducted mini splits, slim ducts. So this is a single air handler that would be up in your attic, and then some short duct runs into maybe a couple bedrooms or a kitchen and a dining room, something like that, to cut down on the amount of indoor units that you have. So this could work out well if you kind of want to split up your zones through a ducted mini split system. And then if you really like in-floor heat, if you have a system in place already, or you're looking at a new construction, they do have in-floor, so hydronic boiler systems, things like that. So we can do that on a heat pump now. Typically, those will have either electric backup or some sort of combustion gas, so natural gas or propane on those as well, just to boost that heat up to the kind of 150, 160 degree mark that's needed for a lot of those in-floor systems. So just kind of diving into the particulars here. So mini splits, again, known as ductless. So these are coming in a lot of different form factors now. So if you don't like the look of that kind of rectangular air handler sitting up on your wall, you can do kind of these slim form factors. You can do a ceiling recessed version of that as well. So all you're really seeing is the louvered opening on the vents, or you have a low mount kind of terminal style unit that you see there at the bottom. So you kind of can pick from whatever you want there. And again, you could have multiple indoor units connected to a single outdoor unit. So forced air. So again, this is pretty simple. You don't see a lot of what's happening on these because essentially they're just pulling out your existing furnace and putting in an air handler. And again, the advantage of this is that you now can use that same ductwork to get heating and cooling in your home. If that's what you want to do and keep that system alive, that's the best way to go. And we'll talk about some of the advantages and disadvantages of some of this stuff coming up here. But really it comes down to the ductwork on existing homes has typically been designed for higher output temperature furnaces. A heat pump tends to push more air at a lower temperature in order to hit that desired room temp. And so if the ducts are too skinny, if they're blocked, if there's a lot of turns in them, sometimes heat pumps don't work well with that. So, good to engage a contractor so they can assess that. And then, boilers, so hydronic or in-floor, all this stuff can be retrofitted with heat pumps now. There's manufacturers that even have heat pumps that'll push out a 160 degree delivery temperature, which is, in a lot of cases necessary for some of those systems. The thing that you need to check on this is that the in-floor loops, they have a specific spacing for the design temperature, and typically propane or natural gas was delivering something around the 150, 160 degree Fahrenheit mark. We need to make sure that the heat pump can actually push out enough heat in order to work with that existing loop system there. So again, always good to engage a contractor that can assess that kind of thing. These won't work with the baseboard style registers. We just can't push out a high enough temperature for those. I think we're getting close. I think Mitsubishi might be kind of on the way towards having something that's workable for something like that. But at this time, I think it's probably, your best bet is if you have those baseboard registers that work on hot water, is to abandon them and go to something like a mini split. And we'll kind of talk options here coming up as well. So the options on replacing these heat pumps, so you don't have to think of this as purely just ripping your entire system out that you have now and replacing it with a heat pump system. You can do that, so if you have a furnace and you really want to get rid of it, you don't want to operate on gas or propane anymore, certainly you can do that. You could abandon a furnace and the ducted system, seal those ducts up and go to something like a mini split. But you've got other options as well. If you want to keep that furnace in place and start to add some supplement with heat pumps, you can have the heat pumps operate for most of your heating load and then turn that furnace on just when you need it. So you could have a heat pump system that's designed to work down into, call it -20 degree Fahrenheit temperature, and then anything below that, the furnace would kick on to make up for the heat loss that's needed at those lower temperatures. You could also do zonal supplements. So if you're finding that you've got back bedrooms or storage rooms, offices, things like that, where they're running cold or they're running hot in the summer, and you just need to get some heat or some cooling back to those spaces, a single zone or a 1 or 2 zone heat pump could really work well to condition those spaces a little bit better than what the ductwork might be able to do. And that way you can kind of balance out the temperature within your home using a heat pump. So a lot of the myths out there. So you're still going to find contractors. You're going to hear people that say that heat pumps don't work here in Colorado. They don't work at our altitude. It's too cold. It's dry air. It's thin air. It's too much snow. And really, if this was 5 years ago or more, I probably would have agreed with you. I probably would have been hesitant to recommend something like this. But I think we've come kind of leaps and bounds here in the last 5 years for heat pump technology to where we now have cold climate rated heat pumps that we know are working out here. So there are hundreds of installs of heat pumps throughout our territory, and we know they're working. The worst one I've seen was up in Summit County. It was up above 11,000 feet at a ski area. The entire outdoor unit was encased in ice. They chipped the ice off of that thing and kicked it back on, and it was still working and pulling full heating load for that hut up there. So they work. And so the things you'll hear, kind of, we'll talk benefits first. So improved air quality and safety, right? So we don't have combustion gas in the home anymore, and what a lot of studies are finding now is having gas appliances and gas furnaces around, all that combustion gas is coming back into the home because they're poorly ventilated. It's causing respiratory issues. So we get better air quality out of a heat pump. Zonal control and comfort. So, if you do mini splits all over the place, or we have a zone system, you can now control the temperature in each of those rooms independent of one another. So if you like your bedroom at one temperature, but you want your living room at another, that's totally up to you. Now you have that full control. Whereas with older systems, you push the same temperature and pressure out to the same home, and it was really hard to control, especially if you had poorly designed ducts that just weren't heating a back bedroom or something like that to the temperature that you needed it. So you have cooling now. So now rather than having window air conditioners or a separate AC system, you now get heating and cooling out of that same high efficient system. So for those few days like we have in June, or kind of those weird days where it's 95 near 100, it's nice to have a little bit of cooling just to kick on for a little bit to supplement what we're getting on our cooler nights out here. So it's becoming more and more common to have new builds, especially going in with cooling. And then smoke, as we have wildfire smoke blow in, and you want to close those windows up in the summer, well, now you can. And you can control the temperature inside that home and not have to rely on leaving those the windows open in order to do so. And especially if we're putting some ventilation in on top of a project like that, you can actually do something like a MERV 13 filter in that ventilation, which will filter out all that wildfire smoke. And now you've got fresh air coming in that's actually been filtrated as well. So the myths that we hear on this stuff, not efficient in cold temperatures. So yes, the efficiency starts to drop off in cold temperatures as we start to approach kind of the 10-degree Fahrenheit range and below. But we're starting to see these heat pump systems that are operating down into, I think, -15 is some of the deeper stuff that I've seen. I know they'll go below that. And that's putting out full heating load just on the heat pump. So it's really just about proper design and equipment selection on these. Needing backup. So if you're doing something like a mini split system, we're seeing plenty of installations going in without backup. If it's an older home, if it's poorly insulated and poorly sealed, and you're doing a ducted system, I may start to advocate for some sort of backup on that, whether it's propane gas or resistance electric. But yeah, you may want to consider some form of backup if you're on kind of that more extreme end of a project. But for most of our heat pump installations, they do not need backup. They don't work at our altitude. So again, we talked about something over 11,000 feet still working. Again, this comes down to proper equipment selection, proper sizing of these systems, which we'll kind of talk about more coming up here, but we know they work. They only work in newer homes. That's not true. It's, again, we talked about having an energy audit done and sealing these things up to lower that heating load. But yeah, it's not necessary. You can have these retrofitted in a home, and we've seen it over and over again. They work out great for those situations. And then they need to be turned down at night to save energy, and that's not true. So the general thinking on kind of legacy technologies for heating is that if you left home or at night, you would turn it down by 8 to 10 degrees, and then you'd come home and you'd crank it back up. And really, heat pumps want to just stay in that same zone, 2 to 3 degrees, and just hover right there most of the time. They don't want big temperature swings to have to recover. So that's kind of the nice thing of these, is that they operate most efficiently when they're going to be most comfortable for you, and you're going to see huge energy savings out of that. And they require a lot of maintenance. So if you ever owned an AC unit before, they don't require a lot of maintenance. So there's on each of those indoor units that you see, there's a reusable filter. You go rinse it out and put it back in. On the outside, you can just hose down or spray or use an air compressor on the outdoor coils if they start to get dirty. But for the most part, those things are pretty self-servicing. Every 2-3 years, we do recommend having a tech just check the refrigerant line set and the refrigerant load on that, just to make sure that nothing is leaked out. But for the most part, they're fairly low maintenance here. And then, so cost comparisons and rebates. So we'll kind of get into the financials a little bit on this. So these figures are a little bit dated at this point, but it's still kind of all relative. So everything's kind of coming up all at the same time. And the things I'll point out here, one is, you can see baseboard electric on the left-hand side there. This is the stuff that we're trying to get rid of. Propane is right up there as well. Propane is really expensive, and that price tends to fluctuate and go up in the winter. And then, the other thing I'll point you towards is that the green and far right-hand side light blue, so that's a heat pump versus a natural gas furnace. We're now seeing, kind of depending on where the price of natural gas is at, that a natural gas furnace is actually slightly more expensive to operate per year than a heat pump system. You don't get cooling out of it. You're dealing with indoor air quality issues. And what we're seeing is that electric rates will tend to stabilize over time, whereas natural gas is forecasted to continue to increase. So if you're looking at the future here of where pricing is going to be at, natural gas is certainly going to be higher here. And then, so now it comes down to cost, right? So some of these systems can be quite expensive depending on the size of the system, size of the home that you need, and what you're trying to install. But there's lots of funding out there right now to offset that upfront cost. And so we have rebates here at LPEA. Our rebate, if you're selecting the right equipment, the stuff that we're recommending here, which would be that cold climate category, which is the second one down, our rebate goes up to $3,500. So we want to see the ratings on those. You can see the HSPF and SEER, so that's heating season performance factor, and seasonal energy efficiency rating. So that's the heating rating and the cooling rating. We want to see those high enough that we know that these are going to work down into some of these colder temperatures here, and that you're going to be comfortable and you're going to be happy with the system that gets installed. So we incentivize that at a higher level to try and get you to select some of that better equipment out there, and offset some of the higher cost as well. So we do have ETS backup. So we took a look at ETS as a standalone option, but you can also do ETS as a backup instead of propane or natural gas. If someone's advocating that your system needs backup, you can potentially explore ETS. You can use that low off peak rate, and it's a really great way to have those two systems work in conjunction for some really cost effective heating. Ground source and air to water systems, we also have rebates on those. So certainly keep an eye on our rebates here too going into next year. We may have some slight changes on them, but our programs will be in place. So, and then just kind of continuing on. So we do have ETS rebates. So if you are considering those systems, that's at $50 a kW. So those rebates tend to come back in the $400 or $500 range for a smaller system. So they are pretty strong. If you're considering putting timers or smart thermostats on there, we've got rebates for those as well. Thermal slab heating, which is pretty uncommon, but if you do happen to put one of those systems in there, we have rebates to cover that. And then the big one here is this $500 rebate. That's a bonus on top of all the other rebates that you get. So lighting and thermostats and induction cooktops, everything like that. If you go all electric in your home, we'll give you a $500 bonus on top of that. More information is at lpa.coop, and that's on our rebates page. You'll see lots of good information on there, including more information and links to heat pumps and things like that as well. So always a good place to start if you're considering systems like this. So there are both federal and state incomes, federal and state tax incentives out there. So the big one that I think most people have heard of is the Inflation Reduction Act, which has brought literally billions of dollars in funding for a lot of different types of energy related things. And a couple of those programs are HOMES and HERA. So HOMES is going to be this performance based program that'll probably launch sometime next year. And that'll be for kind of the lower income bracket individuals. And you'll see probably an agency assigned by the state reach out to people that are pre-qualified for that to do some larger all electric projects and weatherization and things like that. HERA, that is so that's the home, and I can never remember this one, home energy efficiency rebate program, somewhere along those lines. But that is going to be the instant rebates that everyone's been hearing about. So that's the top right there where it says electrification rebates. And so what they're talking about is $8,000 for a heat pump system, along with all these other things that kind of go with an all electric package there. So that's panels and wiring, heat pump water heaters, weatherization, all the stuff that we're talking about constantly. There's going to be some pretty high rebates for that. And the way that the program should run is that it's an instant rebate, so that you could assign that to the distributor or to your contractor, and they could take it off the top of the price there. So it can make your upfront investment quite a bit lower. Those are all 2024 programs. What's active right now, though, are the tax credits. So what is active right now is a $2,000 tax credit for heat pump systems that covers 30% of the system up to $2,000, which most of these systems will qualify for that full $2,000. That system does need to be Energy Star rated, and it does need to meet or exceed the SEER and HSPF values that I've shown down here. So just kind of make sure that the system that you're selecting for your project is going to qualify for that tax incentive before you get too far down the road there. And then the state tax incentive. So this is a 10% tax incentive, and it also waives the state and sales and use tax, which I think is about 2.9%. So you know, a 12% effective tax incentive there on top of the federal and on top of our rebate. That also does need to be Energy Star rated. So again, just make sure you're selecting kind of quality equipment on this stuff, and it tends to fall into those categories. So how do we get started on this? You know, it's always good to engage a contractor. On our website, on our heat pump page under our rebate section, we have a list of quality install contractors. So these contractors have been through a short training for us so that they know how to install and select and install cold climate rated heat pumps out here. You know, so it's always good to engage 2 or 3 contractors, get a few quotes, compare what they're telling you to install and what the pricing looks like, and then kind of work with whoever you think is comfortable there. If you are looking at kind of the electric boiler or baseboard type stuff, that is going to require both an HVAC contractor and a plumber, and probably an electrician if they don't have one on board as well. You know, they'll do a system sizing, do the installation, then within 90 days, all we ask is that you submit for that rebate in that time frame. If you're looking at electrical thermal storage, ETS, you know, you can always reach out to us with questions. But Stethis, the manufacturer of that equipment, has now partnered with Durango Electric Services, so they're a good contact if you're looking for new systems or parts, or if you need service work on the equipment itself. And that one, you know, so they'll come out, do a system sizing, they'll install that. They'll also help you set up this power line carrier. It's the controller for it. We can then help you get changed over to the time of use rate class, and then get you a rebate for that as well. And then heat pumps, you know, we talked about that quality install program. The one thing I want to call out here is, you know, if you're doing a simple project with something like mini splits, or if you're just doing supplemental heat pump installation, then, you know, rule of thumb is typically okay. You know, we can get pretty close on selecting this equipment that it'll work out. But if we're doing more complex things, if it starts to involve something like a ducted system in there or in floor, we really want to see a contractor who's running something called a manual J. The manual J takes into consideration square footage and installation values and windows, and everything that would contribute to the heat loss of the home. It'll come up with a number for how much heat is actually leaving that home at any one time. And then we'll be able to size a system appropriately for that heat loss. And that allows us to really dial into the system, make sure it's not undersized or oversized, and that you're going to be happy with the product at the end there. And then, you know, they can select all the right equipment, kind of dependent on the manufacturer and their specs. Again, 90 days within the installation on the heat pump for the rebate is really all we ask. And then, you know, the big call out there that typically is getting missed is, you know, we do require a copy of the invoice there, and that invoice does need to show both the equipment and labor costs broken out. So Emily, we've got quite a few questions here, so I think
Yeah,
maybe,
I'll go ahead and get started with some questions if you're ready.
yeah.
Um, Thank
Yeah,
you.
before we jump to that, so a couple resources here. So, you know, you've got you know, our energy management team, our rebates page. Love Electric, though, has got a ton of great information on it. And then NEEP also has this pretty inclusive list of what we're calling cold climate rated heat pumps. So if you have any question around, you know, is my system going to work out here, NEEP is a great place to go and look up and see if it's on there. So yeah, throw it back over to you, Emily, if you want to do questions.
Great. Well, thanks so much, John. That was a lot of great information. I know it's kind of a lot all at once, but it was super helpful. And we have a lot of great questions in the chat here. I'm going to go ahead and get started with some questions. Feel free to raise your hand as well, and I'll call on folks, and we'll do a mix of the Q&A and live questions if you'd like. But as we get started with that, we do have one final poll. If you wouldn't mind filling that out, Whitney's going to go and throw that up here about how much you learned, if this was helpful, or if anything new might be available to you in this session. So thank you so much. John, to go ahead and get us started, um, for one of our first questions here, I had a heat pump, which I loved, moved to a new home at Vallecito, which is too cold and high for a heat pump. What's the best heat source you recommend for the Vallecito area?
Yeah, and I know there are heat pumps working up there. I think the journey there is really to look at insulating and sealing that home up, and then working with a contractor who can run a manual J and appropriately size that equipment. Um, so I think it's an option still. If you really don't want to go with a heat pump, then I think ETS is a great second alternative there. You could have a couple room units there, heat a smaller home, pretty simple operation, and it is really cost effective thanks to that time of use rate class that we have here. And so I think that may be kind of the best next option there. You won't have cooling, but up there you probably don't need cooling. So yeah, you can go heating only and take a look at ETS for sure.
Great, thanks so much. Um, we next question. What is the best alternative heat source for a power outage?
Yeah, so this question comes up a lot, and people always say, "Well, if I go all electric, what's going to happen in a power outage?" And really, if you have a power outage, if you have a furnace, if you're on gas or propane, the blower and the controls on that also don't work. So the alternative there when you are installing heat pump systems is either a wood stove can be an option there, or you can explore a generator. So you can actually size a generator that will keep that heat pump system operating through a power outage. And then alternatively to that, we're actually now starting to explore battery systems. So battery storage is a good alternative to get you through, probably a 4 or 5 hour power outage, depending on the battery system, that could keep that heat pump up and running along with some of the other critical loads in your home. And pretty soon here, you'll see us with a battery storage program coming out as well. So that's something else to keep an eye on as an alternative.
Right alongside that, how Michael wants to know, how does the heat pump work with solar? How much energy does a mini split heat pump draw?
Yeah, and always good to engage a solar contractor and let them know that you are considering changing from propane or gas to an electric load so that they can include that in the sizing of the solar system. But they work great. I mean, so if you imagine what's happening there is the heat pump is working around the clock. The solar system will offset some of that usage midday directly. And then thanks to our net metering program here, if you are overproducing some days, you can actually put that into kind of a virtual battery, so the bank, and use that extra production at another time. So I think solar works great with no matter what heating source you're going to use, whether it's ETS or a boiler or anything like that. It's still going to offset a lot of your energy usage on the electric side.
Great. Thanks so much. I'm going to go to a live question. Werner, would you like to speak up? I think Whitney can let you talk if it doesn't pop up for you. Can you unmute yourself?
Okay, unmute. Now I see
There
it
you
because
go.
I didn't see the speaker, the microphone setting before. Okay, I have a couple of questions. Do you have, I'm assuming you have a list of recommended contractors for heat pumps. As you know, we have a heat pump in our house now 5.5 years. It's running which does inflow heat and domestic hot water and cooling. But I'm looking for a contractor at this point, which we haven't had, that can look the system over and optimize it.
Yeah, so that list of contractors that are up on our site right now is, I think there's about a dozen on there, and I would say call a few of those, and yeah, and see who you're comfortable with and who actually knows that system. Alternatively, Werner, I've actually seen your system before. If you want to give me a call, we can kind of talk through specifics on what you're looking for on the contractor side. But yeah, that quality contractor list is pretty comprehensive at this point, and I think that's a good place to start for anyone.
Great.
And
Thanks. Oh,
Yeah, then I have a question. We have a cold spot in our house, in the room where we actually like to be cool, but my wife's desk is in there. Do you recommend an oil-filled heater? It's her desk underneath, or are there mats available that we could lay on the floor to heat up, the location where her chair is? What's your recommendation?
Yeah, and I'll give you a third option there, and that is just a single zone mini split to take care of that room. So that's an option. If the run hours are really, really low on that, and you're not in there very often, yeah, some of the oil-filled space heaters, things like that, could be cost effective, right? They're very low upfront cost, and if they're not running that much, it's not going to cost very much. But you also have an option for the radiant heaters as well. So you can have a panel on the wall that's actually a radiant heater. They tend to be pretty cost effective and efficient. It still works on electric resistance technology, but it'll actually radiate out to the person in the room and keep them warm that way. So that's an alternative you could explore there. But I would price out a single zone heat pump and see if that mini split and see if that works for you.
Yeah, the mini split I
thanks,
thought
John.
of, but it would heat up the whole the whole room.
Mhm.
But the did you say radiating panel
Yeah, yeah. So it's
that's
typically a
mounted on the
ceiling
wall?
mount or a wall mount panel that'll
Okay,
actually radiate out to the person in the room, and that'll heat up that way. And they're
okay.
pretty cost
And
effective.
And I
Werner,
have
we're
one
always happy to
suggestion.
follow up with you afterwards to talk about specific heating
Yeah,
equipment. We'd love to help you select
I
something
will
like
call
that
up
too.
John. And I have
Yeah,
one suggestion,
uh,
but I can wait with that.
real quick, we got a bunch of other questions to get
Okay.
to.
The suggestion is the heat pumps you showed are very close to the floor. Location, south side is really recommended, and off the ground because the snow is also recommended.
Yes, absolutely. Thank you so much. Um, okay, great. We have a couple of questions about the radiant baseboard or radiant in-floor with air to water systems. So I'm going to try to combine them a little bit. Please explain specifically as to why radiant baseboard heating isn't a match for heat pumps. Talked about the reasoning about the temperature, sufficiently high temperatures. However, why would it not work to run lower than optimum temperature for a longer period of time for sufficient heating? Or is there no way that a heat pump can provide enough temps for standard heating needs?
Yeah, and so really, it's just looking at the design temperature for that original system and how tightly spaced those in-floor loops were. Um, the system can only put out so many BTU per hour. It's really the limiting factor there. And so even if we ran that heat pump system 24/7, it may still not keep up with the BTU per hour that is needed there. And then it's also probably typically not going to feel great either if it's too low of temperature. That being said, there are heat pump systems out there that'll deliver 160-degree Fahrenheit temperature, which is pretty typical for what in-floor was designed at. You're going to pay a price premium on that for sure, but it is an option if you really want to keep that in-floor system up and running. And again, I think it's down to a contractor taking a look at that and evaluating what the options are there.
Great. And what kind of heat pump system would be suitable for converting a propane hot water radiant in-floor heating to heat pump setup? Specific recommendations are helpful.
Yeah. So whether it's propane or natural gas, still going to be typical boiler system, and we can retrofit that same heat pump on there. Again, I think the options are that you have a heat pump boiler with a backup on it, or you go something that's a little bit higher end, like that Mitsubishi system. I'm sure some others have some out there now that'll deliver higher output temperatures. So you've got a couple of options. And again, I think it's just a matter of pricing that stuff out to see if it really is worth it for you.
Great. And I have a couple questions about some of the administrative stuff that I can go ahead and answer. So are the rebates expected for 2024 applicable to installs done in 2023? We do change our rebates every year, or there can be changed at each program in each calendar year. So please check in with us at the end of the year if you're going to have a project that straddles both years. Sometimes we do have a grace period, although sometimes when it applies, that's when you would need to submit for that. So please check in with us as you get closer. But we do expect to have rebates for heat pumps in 2024. We'll be releasing more detailed information in the next coming months. And someone else asked about rebates and tax credits are very complex. Will LPA help residents figure it out? That's a great question. We are not tax advisors. We don't give tax advice. So make sure you're talking to your own accountant about tax advice or anything related to that before, if it's going to impact your decisions. That said, we are actively navigating all of these programs, the different rebates, tax credits, our own rebates especially. And we've been in close contact with the Colorado Energy Office and others who will be administering some of those homes and hero rebates that John was referencing earlier on. And we are working on some resources, some public facing, our website for resources around a lot of these incentives. So we are willing to help you figure it out. Please give us a call or email us at rebates@lpea.coop. But please know that we are not tax advisors, and you're going to need to rely on your own tax professional to figure that out. We don't perform energy. Got some questions about energy audits here. We don't perform energy audits, but we do offer $150 rebates for that. They're usually cost around $400, give or take, depending on the size of your home or distance out there. But I would recommend reaching out to having an audit set up first. And okay, I'm gonna see if I can turn a question over to, there was a question about heat pump water heaters and how well they work. John, could you address that one?
Yeah. And so, when we were looking at efficiency ratings, COP often comes up, COP, it's the coefficient of performance. And that is essentially just how many units of energy in versus how many units of heat back out. And so what we're seeing out of the heat pump water heaters is about a 3.5. So 1 unit of energy in, 3.5 units of heat back out. And, so the other question that comes up often is, well, if I run this in the winter and I'm heating the air in my home and that's going into the heat pump water heater, aren't I just kind of robbing Peter to pay Paul? And you are a little bit, yeah, in the winter. What you're really looking at is the delta, so the difference in temperature between outdoor and indoor is what your HVAC system is picking up on before that enters the heat pump's water heater. So you're still a net gain in the winter. And then for all those months out of the year where we're not running heating in our home, then the efficiency goes back up to that 3.5 mark. And so we've got a lot of heat pump water heater studies out there now, and a lot of these in place. And what we're seeing is pretty massive energy savings on the heat pump water heaters, to where they are being incentivized at incredibly high levels because people have kind of seen the writing on the wall for just how effective they are and how much savings is available to these. So starting next year, the price of a heat pump water heater is going to be negligible. It's going to be next to nothing to install those, between our rebates and the tax incentives and things like that that are out there. So they're really cost effective and really efficient.
Great. If you have central heating already, is there any advantage to using multiple mini splits to heat the home compared to a central air handler?
Yeah, and I don't think I touched on this, so I appreciate that question. So the issue with ducted systems in place, in addition to what I had mentioned on the slimmer ducts and having lots of turns in there and having pressure issues with moving a lot more air, is that often these older systems were installed and they're leaky and they're uninsulated. And you often have ductwork actually running through unconditioned space, so outside of all of the insulation in your home. And that's when we have massive heat loss going through ductwork. So now we are pushing the same temperature and pressure out to the entire home, and it's running through cold spaces. And that's why we end up with cold back bedrooms and things like that in a lot of cases. So if we can abandon that ductwork, seal it up, and put mini splits in there, we've got a huge efficiency gain. And now you have different thermostat for each of those indoor units, so you can control all those different temperatures individually and actually put them on schedules so that unoccupied rooms like a bedroom can actually run a little bit cooler during the day when they're not occupied, and you can just increase that temperature by a few degrees to pick back up before you come in there at night. So yeah, I think there's yeah, a lot of gains for mini split systems over ducted.
Great. And we did receive a question earlier this morning from one of our audience members. Can you please explain how heat pump efficiency numbers fully account for additional heating load created by effectively lowering the ambient temperature of whatever utility space, garage, or room in which they're installed? Specifically thinking about water heaters here.
Yeah. And so, so I talked about the net gain from the delta inside to out and how we're actually still a net gain in the winter, although slightly, and then it picks up in the summer. But the rating that you're going to see on heat pump or on water heaters in general is UEF, so the uniform energy factor. That does not account for in situ stuff. So what it actually looks like in your home. That's purely because they cannot account for the thousands of different scenarios that you might see inside of a home. So those are laboratory tested, and they're only looking at the energy use specifically at the water heater. So not including anything in the HVAC rating. That being said, if you're interested and you want to send me an email here or give me a call, I'm happy to send you a couple studies that are showing the energy savings on heat pump water heaters and the net gain that they have, even in climate zone 5 and 6 that we experience here in the mountains. So we know that they're a net gain throughout the year. Yeah.
Right. This is a great question and one we get a lot. I currently have a 200 amp electric panel. What is the typical electric load required for air to air or air source heat pumps or air to water heat pump systems?
Yeah. So operating on heat pump mode, we're seeing somewhere in the ballpark of 2 to 5 kW on a 2 to 3 ton system. It just depends on how hard it's having to work at that time. If you start installing backup electric resistance on something like a ducted system, they may install 8 to 10 kW worth of backup heat, strip heat on that, which is why we're trying to advocate for properly designed systems that don't require that backup, because that is a pretty large load. And then alternatively, a lot of people are running into issues where they need service upgrades or they just can't increase that panel size. So we're starting to explore things like smart panels that can do load limiting, so they can actually tell some of those non-essential loads to turn off, so that we don't exceed that 200 amp panel. And what we're finding in a lot of cases, 200 amps is a lot. You don't ever turn on 200 amps worth of equipment, and that smart panel can be kind of a good insurance policy to make sure that that never happens. Even if you're doing things like charging vehicles and you got hot tubs and strip heat and all this other stuff, we've got solutions to work around that now. So if you want to go all electric, there's lots of options to take care of the panel sizing issue.
Absolutely. And I'll just note as well that my new heat pump system is on a 40 amp breaker. And it's a pretty good size system. So 30, 40 amps is usually fine as far as what you're putting it on there. But yeah, thanks, John. That's a really helpful description of how that load will work. Here's a question about heat pumps operate in what outdoor temperature range, especially duct fed?
Yeah. So what you're going to find is the more you pay, the lower it'll go. And so we're seeing systems that are on the high end going down into, I think I've seen negative 20 degree Fahrenheit operating temperatures at full heating load. And so full heating load means that as that system starts to approach, 10, 5, 0 degree, it's going to start to stop producing as much heat. What they're doing is designing that system out for full heating load. So, we look at that manual J calculation. We know what that home needs to, in order to heat down at that negative 5 degree temperature, and we can size that system out to that. So really, it's a matter of selecting the right equipment, and that's what your lower operating temperature is. I think right now the sweet spot for most of these systems is that they'll put out full heating load at about 5 degrees Fahrenheit. If you want to, you can probably spend a little bit less on the upfront cost of these systems and select something that's going to be in the 5 degree to 10 degree Fahrenheit temperature, full heating load operating range. And some recommendations it is really just to buy a couple of those oil filled space heaters, and for those it's literally less than 5% of the heating season, you can put a couple of those up and just supplement the the heat pump with those if you really need to. Otherwise, just spend a little bit extra money. There's a lot of incentives out there right now to help pay for these higher performance systems that can operate down in those temperatures.
Yeah, absolutely. And I did on a note too on the like the electric capacity thing. There are additional incentives through the Inflation Reduction Act if you do need to upgrade your service panel or have an energy audit, or have some of these additional measures outside of just the heat pump portion. So please do check back in with us, or take a look online for more information about that if that is needed in any of these realms here. We got about 5 more minutes left, so I'm going to try to get to as many as I can here. Thank you guys all for your wonderful questions. Got a couple that are similar. Again, I'm going to try to lump them here. What is the best overall option for replacing a 20-year-old natural gas furnace with an in-floor heat system? And what about a heat pump with in-floor heat in new construction?
Yeah, adding in-floor heat after the fact is really difficult. It's often means tearing up a subfloor or doing something like staple up. So it's difficult but possible. So if money is no object there, then I think it's something you could pursue. But if you're price sensitive on that project, I would say that it might not be in the budget. But it's a possibility. Replacing that furnace, my recommendation on older furnace replacements really is mini splits. Abandoning the ductwork and sealing those openings up so you don't have cold air pouring back in there, and just going to something like mini splits. You'd have one in each what we would identify as a zone. So you may have one for your kitchen and living room, one for a bedroom, that kind of a thing. There's so many advantages to it, and it's so cost effective to do. And they're the highest performing form factor for heat pumps right now. That is truly my recommendation. If you want to keep the ductwork, then you're going to have to insulate and seal that up and make sure that those duct runs are straight enough and open enough, and large enough to accommodate heat pump air output.
Great, thanks. We had a couple of questions here. Elum Pagosa, do you recommend a ground or air source system for a heat pump? And a question here about the trade-offs between air and ground source heat pumps.
Yeah, good question, because it comes up a lot and it's difficult to assess. So ground source is more expensive, but we do get higher efficiencies out of it if it's on good ground. What is kind of being learned here is that if it's not the proper soil, that we can actually pull too much heat out of the ground and not return enough heat in the summer in our climate, because we have such a low cooling load out here. We're not putting a lot of heat back in to that ground. And you think, well, it's the earth, it's huge, how could we possibly do that? But we can actually pull enough heat out of that over several years that we no longer have enough heat in that zone, in that coil zone. And so really have to have someone that knows what they're doing come and assess that and make sure it's actually going to work out there. And that's why we tend to steer people towards the air source. It's lower cost, it's cost effective, it's efficient. In the long run, I think it's probably the better investment, unless you have a really large system that you need to operate on a ground source, or you're sitting on something that's going to be able to act as a heat sink with a net heat loss over several years. And Emily, you're muted actually there. Yeah.
Muted myself. Sorry, guys. We did get some feedback on here that some of our qualified contractors sometimes are perpetuating some of our myths, the myths we addressed here. We appreciate that feedback. That is something we're trying to work on more actively with our contractors and continue to upkeep with education and training. So if you do have anything specific you'd like to chat about, always feel free to reach out to John or I. But thank you so much for that feedback. Let's see. What quick question. I'm here. We're building a small separate studio from the house. Which heating system would you recommend?
Yeah, single zone heat pump. Yeah, just a real simple mini split. Really cost effective, very low cost, especially with all the incentives that are out there right now. I think that's an easy one. And then you can actually have a smart control on it, so you can control it from your phone from inside the house. You can see what temperature it is out there, and if you know you're heading out there in a few hours, you can just have that thing increase the temperature for controlling it that way. So yeah, I think that's probably the best way to go there.
Well, I'm gonna try to fire off a couple last
Sure.
quick ones
Yeah,
here,
yeah.
and then we're see if we can get most of these
Rapid fire.
rapid fire. Is there any assistance in determining best system for DIYs?
We don't. I'm certainly willing to talk through stuff with you and point you towards resources, but we don't have that right now. I know there are a couple manufacturers out there who will assist you. One of those being Arctic will actually help you design a system out. Other than that, if you're looking at something like a Mr. Cool system, you're kind of on your own on that. So you'll have to do a bit of research online for those.
How about a heat pump clothes dryer? Do they work well?
Yes, a super high efficiency, and we don't have a vent going out through the wall, so we don't have cold air pouring back in. The downside to them is they're higher maintenance. So we've actually been seeing some reviews on these where they actually need to be vacuumed out the worst I've seen is every 2 or 3 loads in order to maintain that efficiency. So if you're willing to do the maintenance on those, I think it's a good idea. If not, I would maybe wait out the heat pump dryers for a little bit here and see kind of where the performance goes in the next few years.
That's great. Can I add a heat pump to an HRV ducted system?
Yeah, no, there'll be 2 disparate systems, right? 2 separate systems. So the heat recovery ventilator needs to do its own thing on its own, and then the heat pump would actually be its own system. So whether you're doing a mini split or something like that, and I wouldn't want to mix the 2. Just let the HRV do its thing on bringing fresh air into the home and doing the heat exchange.
Awesome. Well, I think we've largely gotten to most of these. Last quick fire. What's the opinion of instant water heaters?
Yeah, if you're going, gas or propane, it works. But again, if you're trying to get rid of gas or propane, the next best option is a heat pump water heater. The electric instant water heaters are a huge load. It pulls a lot of wattage all at once, and they're pretty costly. So I would steer clear of the electric, and honestly, make a heat pump water heater work for you. It's really a great option right now.
Steve Zeller, are you still on? I'm so sorry. I did see your hand up earlier and I apologized. I got stuck in I don't think he's here anymore. We'll reach out to try to get that answered. Thank you so much, John. Thank you guys so much for your questions. You guys have been a wonderful audience. If your question wasn't answered here, please reach out to us. A lot of really specific questions about what about this setup in my home. And we're really here to be your energy advisors and help you get some of these questions answered and pick your systems. Or help you figure out where to go. So thank you guys so much for being here and for all your participation. John, thank you so much for a great presentation. And I hope the rest of you enjoy your afternoon. Thanks so much.
Thanks, everyone.